So this is a continuation of my part 1 to this video, and okay, we are given a volume and we want to find the maximum volume. So the in the application of this differentiation, the trick is to do this. Let's say if you find the first derivative and equate it to 0, you will find the value of the x that will maximize or minimize the volume. So what we do here is the a is actually a constant in this question, so we just only need to differentiate with respect to the x. So what I do here is, using the product rule, I just keep 1/4 root 3x, and then I differentiate this term with the chain rule. So 2 I'll bring down, and then the power of 2 becomes 1. So I keep everything inside, and then I proceed to differentiate what is inside. I get -2 root 3, because differentiate a will give you 0, differentiate -2 root 3x will just give me -2 root 3. So, and then I proceed to keep the other side. So I keep a -2 root 3x squared. This is the product rule. So and then I differentiate this term. When I differentiate this term, I will get just root 3 over 4. So I equate it to 0. So, and then I'll equate it to 0 in order to find the maximum or minimum point. But let's see how. But before that, I would like to simplify this term. So because I'll get because this one is root 3, okay, root 3 multiplied by root 3, therefore I get 3, correct, and x, therefore I get an x here, and 2 multiplied by 2 is 4, 4 divided by 4 is 1, so these terms disappear, and this minus I bring in front, and then I'm left with a -2 root 3x that's here. And then for the second term, root 3 multiplied by root 3 over 4, I'll just keep it here, and then this term I'll just keep it here. And then I would like to factorize out, because this and this part is the same, right, except there's a square here, so I factorize out 1, the power, this with a power 1, so this term disappear inside, will disappear, we have -3x plus, then this part is root 3/4 multiplied by 1 of this term, so this disappears, so just root 3/4 multiplied by a minus root 3/4 times this term will give me 4, 2, so left with 2, root 3 times root 3 give me 3, and the x is just here. So because I've already factorized out 1 of this, so it's just root 3/4 times this without the square, right, to give me the inside. So this part I proceed to simplify, okay, -3 over 2 is just -9 over 2, and with the x, so then plus root 3/4 a here, so I get a 0 here. So yeah, so then I have the x equals to a. Now since either this term has to be 0 or this term has to be 0 in order for my first derivative to be 0, so this is my x from the resulting solution from this term is just a I bring over, -2 root 3x I bring over to the other side, and then I divide both sides by 2 root 3 to get the solution here. And simply this part can also be worked out. It's just what I do for, let's say for this part, is just 9 over 2 minus 9 over 2x plus root 3/4 a. I give you an example, equals to 0, right? So that means this part, if I bring over, I get 9 over 2x equals to root 3 over 4a. And then when I multiply by 2, this becomes 2, and then later on I multiply by, divided by 9, so 9 times 2, so I get root 3 over 18a. So that's just what it means. So let's say now I get 2 solutions. How do I know which x will give me the maximum or the minimum point? One way is to do the second derivative test. It means second derivative test means dv dx greater than 0 will give me a minimum point. That means I must find dv dx and substitute this point to see whether it is greater than 0 or smaller than 0, or equals to 0. If it's equals to 0, then I cannot conclude that whether it's a maximum or minimum point. Then I need to use the first derivative test, but I'm not going to go through it here. So if you have question, you can feel free to email me at feel free to email me at info@hour.com. Okay, so now for this part, if I substitute this into this x, right, into the volume, I realize that 2 root 3 will cancel with my 2 root 3, and a minus a will give me 0. So the whole term will become 0, volume will become 0, so it wouldn't be the maximum point. It would be the minimum point for a volume is 0. So what if I substitute this term inside? What would I get? So the volume that I would get if I substitute inside this point would be 1/4 times root 3 over 18 a times root 3, then a minus 2 root 3 times root 3 over 18 a, right, just substituting into this x, and the whole thing would square. So usually I would like, for the second bracket, I would use a square bracket to differentiate to help me with my computation. So how I do this usually, okay, root 3, I'll take care of this, right, root 3 over root 3, so I'll times root 3 will give me 3. 3 divided by 18 will give me 1 over 6. 1 over 6 times 1 over 4 will give me 1 over 24a. I settled all these terms here, and now I would settle the terms here. So now I have a root 3 times root 3 will give me 3. 3 times 2 will give me 6. 6 divided by 18, so I'll get minus 1/3 a. So again, these two terms will give me 3. 3 times 2, 6. 6 divided by 18 is 1 over 3. So a here. So, and then I have a square over here. So 1 over 24 a, but inside would have 1 minus 1/3 will give me 2/3 a and square. So 339, okay, so 224 first. 224, 4, this will give me 16. 16 times 1 over 6 times 1 over 9 will give me 1 over 6 times 1 over 9 will give me 1 over 54 a square, and a will give me a cube. This is my maximum value of v, and yep, that's it. We would like to take a look again, right, and that's it.